The objective of today's math lesson is to review and practice using lattice for multiplication of whole numbers and decimals. You learned lattice in 3rd grade, so hopefully this is a lot of review. What's new this year is that you're going to be multiplying numbers that contain decimals. Let's start by reviewing a lattice problem that does not contain any decimals, just to refresh your memory about what these problems are all about. So say we have a 2-digit by 2-digit multiplication problem. Let's say, oops, here's my pen, 26 times 52. So the basis for lattice is this funny set of boxes. The number of boxes depends on how many digits your two factors are. We have a 2-digit, 26, by 2-digit, 52 factors, so we need a 2 by 2 box. The first factor goes on the top, the second factor goes on the side. And this is actually the trickiest part of the whole thing, drawing your lines just so they go through the corners of the boxes. And now you're ready to actually do the multiplication problem. So you multiply the numbers that meet and put the product of those two numbers in the boxes. So let's start with 6 times 5, which is 30. We're going to write 30 in that box. 6 times 2 is 12, so 12 goes in that box. 2 times 5 is 10, and 2 times 2 is 4. Notice when the product is a 1-digit number, we need to use a 0 to hold that place. I guess this is the only box that happened. Now we've done all of our multiplying. Now we can add all of our products up and get our final answer. And the way we add is along these diagonals. So first this only has one number in it, 2. This diagonal has 3 numbers in it. This diagonal has 3 numbers that need to be added, and this diagonal only has 1 number. So let's go ahead and add them up. 2, 0 plus 1 plus 4 is 5. 3 plus 0 plus 0 is 3, and this diagonal also only has 1, and now we have our final answer are these 4 numbers that we got by adding the partial products. And if we write that in standard notation, whoops, didn't mean to do that. If we write that in standard notation, we end up with 1,352. Hopefully this process seems really familiar because you practiced this a lot in 4th grade. Now we're going to look at it when the factors have decimals in them. Okay, let's look at this problem, 3.5 times 6.2. I've already set up my lattice box with the two factors. I'm going to go ahead and just ignore the decimals right now. I'm going to pretend that they don't exist while I fill in this lattice box. So I'm going to do 5 times 6, 30, 5 times 2, 10, 3 times 6, 18, and 3 times 2, 6. Remember, next I'm going to add my diagonal columns. So in those diagonal columns, just to remind you, here, 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 and here is what I'm adding. So we have a 0 in that column. 6 plus 1 plus 0 is 7. 0 plus 8 plus 3 is 11. Just like in the traditional algorithm, we carry the next place value up. And now we have this 1 plus 1 is 2. So in standard notation, that's going to give us a number that looks like this. Now our problem, our two factors had decimals in it, so you might be assuming that somewhere in that answer there should be decimals, and you're right, there should be a decimal somewhere, but the question is, where should the decimal be? Remember a couple days ago when you did magnitude estimates and I said that they would come in handy in the future for checking the reasonableness of your answer? This is what I was talking about. Let's go back to our original problem. 3.5 is about 4. 6.2 is about 6. 4 times 6 is 24. So 24 is my magnitude estimate. I know that this problem over here should give me an answer of about 24, because 24 was my magnitude estimate. certainly 2,170 is way, way wrong. So where do we want to put the decimal? We could put it here. We could put it here. We could put it here. We could even put it here. If we put it over here, we have an answer of 2,170, and we know that doesn't make any sense. Does an answer of 217 make sense? Well, we know it should be about 24, so no. How about 21.7? That's pretty close to 24. Our other option would be 2.170 or 217 thousandths. Both of those are nonsense answers. So we can see by checking with our magnitude estimate that the only reasonable place to put the decimal is between the 1 and the 7, making that answer 21 and 7/10 or 21 and 70/100. So using a magnitude estimate is an excellent way of figuring out where a decimal goes in your answer, but there is actually also a rule, which I'm going to tell you now. It's always okay to use the magnitude estimate to figure it out, but if you're wondering what the actual mathematical rule for using lattice with decimals is, here it is. See how the decimal for 3.5 is right there? The decimal for 6.2 is right between the 6 and the 2. If you follow these two decimals until they meet right here in the center, at that point they follow the diagonal down, and that's where the decimal ends up. So the two decimals meet in the middle and then just follow the diagonal. Let's look at one more example. This example is 1.2 times 64.9. It doesn't matter how many digits are in each of the factors. You can draw your lattice box in whatever configuration you need to accommodate any size multiplication problem. This problem is 2 by 3. So I've done everything but draw my lines. Got my lines drawn now. Before I even start this multiplication problem, I want to do a magnitude estimate just so I know when I get my answer where the decimal place should go. 1.2 is pretty close to 1. 64.9, I'm just going to round that to 65 because I know I can multiply anything times 1. So I'm looking for an answer that's around 65, an answer that's probably going to be in the tens place. So let's do my multiplication now. 2 times 6, 12. 2 times 4 is 8. 2 times 9, 18. 1 times 6, 6. 1 times 4, 4. And 1 times 9, 9. I'm going to add my diagonals. 9 plus 1 is 10, plus 8 is 18. I'm going to carry that 1 up to the next place value. 4, 5, 6, 7. 0 plus 6 plus 1 is also 7, and that's a 0. So my final answer looks like this, 7, 7, 8, 8. Well, look what we were supposed to get, an answer around 65. Without any rules about what to do with decimals, I know that that is the only reasonable place to put my decimal. But let's check it with our rule that we just learned. Here's this decimal. If we follow it down, here's this decimal. We follow it across. Where those two lines meet, that's where it travels down the diagonal and parks. And sure enough, 77.88 is the answer we got using the rule. Our estimate got us the right answer, no problem. Now it's time for you to practice yourself. Go ahead and turn to page 55 in your math journal. See if you can do all of those problems. They will ask you to do magnitude estimates before you do the lattice and work out the final answer. But see if you can get all those problems done on page 55. If you have any problems, just make sure you're ready to talk to your teacher about it in the morning. And I'm sorry, we don't have any guest doggies on the video tonight. Good luck, have fun.